Rohini Kankar, Infrastructure as Code with AWS CDK is her topic for the day. Rohini is a senior developer advocate at Amazon Web Services and brings over a decade of experience in information technology, primarily focusing on cloud computing technologies. With AWS for last 6 years, she has worked on multiple roles, including being solution architect in ASEAN and India. As a SA, she has focused on the needs of cloud native customers and is actively involved in the DevOps and container space. She has been leading conversations with businesses of all industries and sizes of innovation as they deploy critical workloads onto the cloud. As a developer advocate, she is passionate to share her experience on building architects with best practices and help strengthening builders of tomorrow. With that, over to you, Rohini.
Hey, Savita, thanks for the introduction. Let me just quickly share my screen. And can you confirm you can see my screen?
Yes, Rohini. Is it in presentation mode? I mean, you can just put it into presentation.
Yeah, I'll just go into presentation mode.
It's popping up.
Awesome. Thank you so much. So I have 30 minutes and I would like to use all of those. So let's start with our topic for today is infrastructure as code, or I would say infrastructure is code with AWS CDK, that is Cloud Development Kit. My name is Rohini Gaonkar, and you guys can reach out. Everyone can reach out to me via Twitter and LinkedIn. And as Savita mentioned, I've been with AWS for 6+ years in multiple roles. Happy to answer questions with respect to AWS or cloud in general. Without further ado, let's just discuss our agenda for today. We're going to definitely talk about CDK, the why, the what, and how with a quick demo. And towards the end, I have a surprise of CDK 8S, CDK8s with a quick demo. And then I'll also showcase how you can learn and contribute back to these projects. So quickly, I won't take a lot of time. I just wanted to talk about the evolution of infrastructure provisioning in cloud, right? As we all begin using cloud, we all start with, the AWS Management Console or any kind of UI that will help us get started quickly. But over the time, we realize that, it's not reproducible, and every time you want to do a certain activity, you have to go via the console, use so many, wizards, and just keep clicking, and it's very time consuming if you have to host your production applications on the cloud. So as engineers would do, we write scripts, and we write these scripts that will ultimately call the AWS SDK, and then it will host your applications. Good to start with, but there's a lot of boilerplate we have to write. There is a lot of questions like, what if something fails, how do I retry, how do I roll back, what about configuration drift, and there are a lot of questions that really go unanswered when you just write a script and deploy. So the technology evolved. We started writing CloudFormation templates, or you would know Terraform templates as well, and these would in turn, execute the AWS APIs in the backend and create the AWS infrastructure for you. Uh, so this was good because now you could have a reproducible .json or a .yaml file that you can run, you can create, you can update, you can also use it to delete resources in your AWS environment, right? So it's easier to automate, helps you reproduce. There's a lot of configuration syntax that you can follow. So you can work around that, but then it would still had no abstraction. You still had to, like, I used to be a support engineer for AWS, and I was a CloudFormation SME, and this was like 6 years ago, 5 6 years ago. And then it was just JSON. YAML was also not announced with CloudFormation. And I remember it was so difficult for customers to just copy paste lines and lines, like thousands of lines of code from one document into another. And it would really get messy after a while, because then you just have to edit a document which not everyone is so happy working with, right? And so came with that, there were a lot of these document object models. I believe we all remember Troposphere or GoFormation as resources, which would let you write code in your favorite programming languages. They would generate the CloudFormation templates or Terraform templates in the backend, and that you could use to deploy it to your AWS cloud. Now, this was good because now I can use my familiar programming languages. I can write real code. I can use my IDE. I can write my if statements and for loops and whatnot and write code. But still, abstraction was not built in. Like if you see the example, just to create a VPC, you had to actually write 218 lines of code in Troposphere for just VPC and subnets. These are all AWS base infrastructure related services or resources that I'm referencing. Um, I'll always be happy to answer any questions with respect to these if you have more doubts about that. But I'm going to be focusing more on CDK. And this was good because, okay, I can write real code, but then I was still missing a major point was abstractions. That's where CDK came into being, right? So you can still write code in your familiar languages. There is a lot of languages that it supports. We'll talk about that in detail. And there is something called as constructs, which helps you abstract a lot of these details that you would essentially provide in a CloudFormation stack or in Troposphere stack itself. So, for example, the same 218 lines of code that you had to write in Troposphere, now with CDK, you would just have to write this one line of code and it would create the CloudFormation stack in the backend for you. And that's the basic crust of what is CDK and why CDK, right? So without further ado, I'll just go quickly deeper into CDK. So CDK was announced in August 2018. It went GL just last year, 1 year ago, with TypeScript and Python, and later on Java and C# were supported. We just recently announced the public roadmap, and CDK 8S, CDK 8s, is announced in an alpha stage just last month, May end almost, in TypeScript and Python. If you want to know more about the roadmap, it's available on GitHub, and if we all contribute more, we'll see some awesome stuff coming out of CDK in future. So to understand CDK, you have to understand the construct tree. Okay. And this is a core framework on which CDK fits in. So when you initiate a CDK app, it's a CDK application, you can use the different languages to initiate the CDK application. You would essentially create one or more stacks inside the CDK app. And this stack actually correlates directly to the CloudFormation stacks that you see. Okay. So these would actually have one-to-one relationship with the CloudFormation stacks that you would define. And each stack could have one or more constructs in it. Now, a construct could be just an AWS resource like S3 bucket could be a construct in its own, or a construct could also mean multiple resources or multiple constructs into one. We will dive deep into constructs, but to understand at a base level, you could understand that it could be any resource or resources that you would define in the AWS cloud would come up as constructs. So what happens is you synthesize this application and this command CDK synth. You synthesize this application and generates a CloudFormation template that you could give to CloudFormation, and it will in turn like create the resources for you. So the same thing, that's your core framework. You execute the CDK CLI, you use synthesize or synth as a command, generates CloudFormation template. You could also use CDK deploy, and it will synthesize and publish the CloudFormation template to CloudFormation, and it will ultimately create the stack for you. So main components of CDK, it's a core framework, there's a construct library, and there's a CDK CLI. That's all the three things that you need to remember when you're talking about CDK. Okay, and let's do this. Construct library is available online. When it was initially launched, it was a bit, not so upgraded. But now, if you go ahead and see it, the construct library, you can just click this link, or you could just search AWS CDK construct library, and you should be able to see it. And there's a lot of information available in the construct library itself, like the languages it supports, is it stable, is it experimental, and how do I initialize it, what are the properties supported by this construct, what are the methods supported by this construct. So there's a lot of information that you can find on the web UI, and you can also find it in VS Code. I'll show that when I'm showing in my demo. And coming to the CLI, this CDK bootstrap needs to be done once in every region of AWS. This is just CDK trying to create like S3 buckets that it needs to, to install the CDK toolkit in your AWS environment. CDK init, as simple as it mentions, it creates a new CDK project. So you could just say CDK init, and you can create an app, you could create a library, you could create a sample app of CDK, and you can mention whatever language you need. As simple as that. If you want to add more constructs into your project, you just have to give this command at your terminal, like npm install that construct, and just import it in your code. I've recently started learning TypeScript. It's just been a month or two. I've been experimenting and learning TypeScript. So it's quite fun and quite easy for me to work with programming language. So I just thought, why not learn TypeScript? You can also compile your code. So when you're using TypeScript, TypeScript source needs to be compiled to JavaScript, right? So every time a modification is done to the source file, you want them to be compiled to .js, and that's why I keep running npm run watch in one of my terminals, and it will continuously keep compiling whenever there's a change in the file. CDK synth or CDK synthesize, as I mentioned, it synthesizes and prints the CloudFormation template for the stack. CDK deploy synthesizes and deploys the stack in your AWS account. Destroy talks for itself. CDK diff actually will compare your stack. The currently you have a local template file or any deployed stack, and you can do a differentiation. So you could say, I've done these changes. How does it look? Does it do anything to the resources in there? Does it delete anything, update anything, or what's the difference between the current file that I have, or what's the difference between the one that I've deployed? So before we get into a demo, I just want to give you a quick deep dive on to constructs, right? So there are three types of constructs: low level, high level, and higher level constructs. And as I mentioned, constructs are nothing but AWS resources or combination of AWS resources. So low level construct would be something that directly corresponds to the AWS CloudFormation resource. So for example, you say EC2 is one of our service, I would say anything starting with CFN would be in a low level construct. So it would be AWS EC2.CFN VPC. That would actually directly represent a CloudFormation resource. Okay. So as I mentioned in an example, I would say I'm initializing this construct, and CIDR block is a required property for the CloudFormation resource. Okay. So I have to mention the value for the CIDR block. Okay. And that corresponds to a CloudFormation template where it will connect, it will synthesize into a .json or .yaml file, and that would mean, okay, it's type VPC and it has a property CIDR block, right? You could also see that it also writes the metadata. So if you want to know which stack this or which uh, application the CDK belongs to, you can actually find that in the metadata property. But here, when I mention the VPC, it's just going to create a VPC. You have to then separately mention the subnets, the public subnets, the private subnets, the route tables, and all other networking related resources you need to execute in AWS, right? So then there are these high level constructs. Now, high level constructs offer you convenient defaults. They have one or more constructs in them. They form basic patterns that are required. So, for example, when I say I need a EC2.VPC, it is actually going to create VPC, and as per best practices, it's going to create two public subnets, two private subnets, and internet gateway and those associations, and it just does everything for you in the backend. You just have to give one line of code, and it will generate so many lines of code, and CloudFormation for you. So that's a lot of code that I didn't have to write, and it's just one time configuration for me. Then there are high level of constructs called as patterns. Okay, so patterns are a bit more built on the basic patterns, right? So they could be common architectural patterns that you would be needing. For example, ECS. Suman mentioned in one of the sessions today, ECS is Elastic Container Service provided by AWS, and it's for running your Docker containers onto AWS in a managed format. So you could actually just write few lines of code in your favorite programming language, and it will create the CloudFormation template that you can just push to CloudFormation and have your environment up and ready, right? Just this week, I think 22nd June itself, we announced solution constructs. And solution constructs are nothing but patterns. They are production ready, well architected applications. These are pre-built, vetted by AWS solution architects, and these could have multiple service, and they are like configurable. So they will have certain defaults, but if you want to configure them, you could also do that. So for example, using CloudFront with S3 is a very common architectural pattern, right? So that is still available in solution constructs as a pattern. So have a look at it, play around it, and give us a feedback about what you think about these different patterns. And I did mention this before, so you should always look at the construct library. So I've given an example of EKS here, where you could see which resources are stable for you to use in production and which are really experimental. So I would really not, recommend using them in production. You can test them out, play with them until they go really stable. So I did make my repo public just an hour ago, but you can have a look at the demo in my GitHub repo if you're interested in. It's a very simple demo. Uh, so I'm hoping you can see my screen. So what you could see here is
Hey,
my
Rohini,
VS Code.
just
Hey,
for a second. I mean, you can just zoom in a little.
can you see my screen? One second, let me see what's happening. Uh, okay. Yeah, don't worry about the code. I'll showcase that. Okay. So if you see this is the microservices app that I've created. It's a sample app, and that app is created by CDK in it. So you will get a typical layout like this, where you'll have bin, which will be like your entry point for your code. Let me see if I can zoom this out. I'm not sure how do I zoom this. Okay. So anyway, what I wanted to show you was that you could actually have uh, this is my starting point. So I've actually initiated a CDK app here, and what I'm saying is these are my different stacks, and I want to initiate these different stacks via CDK. I'm here at my npm watch. Okay, and let me show you this in the CDK Explorer view. This is VS Code, so if you play around, you can also see the same format in your VS Code as well. So I have a CDK Explorer preview section where it shows me what is my app, what are the three different stacks that I've initiated in this particular app. So you can find the names. You can also find what are the resources that are defined inside each of this app, right? And I have just a second for this. Sorry. Okay. Sometimes it does this. So what I do is, as a good chef, what I've done is I have already created the CloudFormation stack. So I've actually deployed the base dev network. I can also show you a sample. I don't think I have enough time, but I've also done this beforehand because it takes almost 10 minutes or something for it to actually deploy these many resources. So if you go here, if you go and see my CDK out, and you see the template file, and I'll just show you what it does. So this one has actually generated, okay, this not this one. Okay, we'll see later on how to do that. I think I have a screenshot somewhere, but this one has actually generated CloudFormation stacks, and I've created these beforehand for you because it takes a while for them to create. So I've created a base stack that is going to be for my development network. And this stack has a lot of VPC related resources that are created within this CloudFormation stack, right? And what I've done is to showcase simply that, it could be a microservices application. I've defined two microservices, let's say Apple and Blueberry. I was eating some fruits when I thought of defining them, but in Apple, it's something simple as I'm defining an EC2 instance, and this EC2 instance, you can just write a for loop, and you can have as many EC2 instances as you want. And the other one is interesting because this one is actually the EKS cluster that I've created on AWS. Okay, so I'm just picking up a demo user. I am user. I am creating an EKS cluster with kubectl enabled, and I've also given it a role that I can use to access kubectl, because when you this is something I want to discuss in detail, so I'll maybe writing a blog about it. There's a lot of information about it on in the documentation, but essentially when you create Kubernetes using like services like CloudFormation or CDK or any other service, uh, by default the user that created that cluster only gets access to that cluster, right? And right now I'm using a different user that needs to work with this microservice, right? So what I've done is I've added that demo user's credentials to the cluster admin, and what I've done is I've also updated the EKS or Kubernetes's authentication with this particular user. Okay, and this also creates an on-demand auto-scaling group with respect to the cluster. So I'll quickly show you my console, because then it's easier to understand. So what it has done is it has already deployed the stack, and it has created these nested stacks automatically. Okay, so if I have to show you, so it actually created a lot of things for me. And here is, so I just said CDK dev1 blueberry ms, and it has actually gone ahead and deployed it to CloudFormation. It saw that my blueberry stack is dependent on the main stack. So if you go here, if I see I say that blueberry is dependent on dev stack as a stack, and it has already gone and checked, oh, does base dev network exist? It says okay, it does exist. These are the outputs of it. Now let me go ahead and deploy my dev1 blueberry microservice. And before it does that, there's a lot of IAM related changes that it has to do, and security group changes. So it's going to ask me, uh, are you okay to proceed? And I said yes. And then it took its own sweet time to actually go ahead and deploy the case cluster into my AWS environment. In the outputs, if you notice, I received a configuration command as well. So this is the configuration command I received in the output. This is automatically generated when I actually mention just EKS cluster. Okay, so when I just mention this, it's automatically understands, okay, the output command config should be there, and that's where it has given me this. So what I did was, just to show you sample, first I ran kubectl get service unable to connect. Okay, so it didn't find the configuration that I had to do. I just created this cluster. Now what I'm going to say is, okay, so please update my kube config for this cluster, right? So I just ran this command, that EKS update config, and it actually updated my cluster. I again tried to do kubectl get service, and it was able to pick up the cluster IP, or this cluster IP comes from autoscaling. So autoscaling launched one instance, and that instance has nothing going on in it. It just launched a one instance. And that's as simple as what we try to do with kubectl. So if I had to show you once again, so you could actually do any commands like CDK list, and it's going to go and see what are the list of stacks you have. You could just go ahead and say CDK deploy. I've just done that here. So you could just see CDK deploy, and it will go ahead and start doing the deployment method, right? So let me quickly go back to my presentation, because there's an end to it. There's a fancy end to it I want to show. Uh, So what we did was we defined an application, we defined the stacks, we created different constructs in it. We use CDK CLI to synthesize and deploy it to CloudFormation. Uh, that generated a lot of lines. Yes, this was what I wanted to show. But JSON editor actually generates a lot of these things with just one command that I run, right? And just to give you a pictorial, some of us understand architectures much better in an architecture form rather than text. So it in AWS Cloud, it created a VPC, it created public subnet, two public subnets, two private subnets, two NAT gateways, attached elastic IPs to these, associated the route tables to your subnets, create an internet gateway, associate that with the VPC. So there's a lot of things that's just one sentence has done for us, right? Just to summarize, you can now create, you can reuse these components. So you can write the composition of these constructs as reusable components, and you can share it like any other code. So you could write a stack, or you could write a construct for your kind of an application or your microservice, share it with other developers, let them use the same format to deploy their environments and work with it, right? So you could share it within your company, you can go ahead and share it with the community. So it's in the end, it's just real code in your ID. Now, no more you're writing JSON templates or YAML templates. You're writing actual code that you relate to very easily. You can use your object-oriented techniques, to create the model of your systems. You could write a logic. You could test this infrastructure as code. Now, you could continue using your test workflows or your code review workflows with the same code, with this code as well as you do with your normal development code. Another interesting open source project that is being announced is JavaScript interoperability interface. Okay, it allows your code in any language to naturally interact with JavaScript classes. It is this technology that has enabled the CDK to actually deliver polyglot libraries from a single code base. This is how we were able to provide you support for so many languages, and in the end their source code comes from one single place. So if you're interested to check it out, go ahead and find it on GitHub. Quickly, I wanted to show you CDK 8s, that is CDK for Kubernetes. Again, I just made my repo public, so if you have any interest, go ahead and check it out. uh, give me any feedback if you think I'm new to TypeScript, so I'm still learning. But if you have any feedback that I could do things in a better way, happy to hear that as well. Quickly give you a quick, rundown of what CDK for Kubernetes is. We understood what CDK is, right? It gives you a lot of abstractions for a lot of these resources that you need to create. And with Kubernetes, it gives you a lot of abstractions for the native Kubernetes resources. Okay, it's still day one, so it's still in alpha stage today. We have big things planned. Check out our roadmap on GitHub. We just support Python, TypeScript, and JavaScript today. We have plans to add more languages as we go. Um, Important to remember, this is not just for AWS. Okay, so CDK 8s or CDK for Kubernetes is for the entire community. Is work can work agnostic, can be agnostic as in it can work with Kubernetes cluster anywhere, anywhere that you have hosted, not necessarily to be on AWS itself. And we love our contributions, so please go ahead, and if you're interested, just contribute back to the open source project. Same with CDK. CDK it has the same similar construct tree. It also will initiate a CDK application. However, instead of stacks, now you would have charts which would directly correlate to your Kubernetes manifest file. Okay, so you would have charts, and the constructs here would be your Kubernetes resources. It could be deployments, it could be services, it could be replica set or pods, anything that you need to interact with Kubernetes deployment itself. This generates a Kubernetes manifest file that you give to Kubernetes, and it creates all your resources, right? Let me quickly show you a demo. So what I've done here is, in CDK, what I showed you was how it was easy to actually define your network stack, you created a VPC, how you could define microservices, how you could create EKS clusters. Now, what I'm going to do is just let me copy this. This is the configuration of kubeconfig, and this is this is a sample CDK project. So if you notice, it's same like my main.ts, and my outputs of Kubernetes will be in this folder. I've already synthesized the file, so you could just say CDK s sync, and it's already, it's the same file. I've not changed the code at all, so it will be the same file. And what I've done is, in the code, I've defined a label. Okay, I've defined I've defined the service here. I'm saying I need a load balancer for my API, and in the end, I've just defined deployment. And if you notice, in the deployment, obviously I've given the labels. I'm using a sample Docker image from Paul, and I've used that sample image, and I've added a custom message to that sample image, right? So I'm just going to say, I just deployed this on AWS EKS using Kubernetes. So I just copy pasted the command from EKS output. So I'm just going to paste that, and it takes a bit, but it will say it has updated the context for me. So let's now try kubectl get svc, and you should see the same. Once again, it takes a bit of a while because of my internet acting up. Let me see, meanwhile I can zoom in something. Okay, so if you see, that's just the one I'd created using auto scaling, right? Now what I'm going to do is kubectl apply -f. This is your normal kubectl command that you do. You just say distribute, and you just say the YAML file that actually CDK synthesized, right? So it's the same YAML file that I'm going to mention, and I'm going to say apply. Let's give it a minute to actually do that. Till then, zoom in. Okay, I can see it now. It's not going to zoom in. Hope that is visible to you. I will have to give it a second. So what it has done is, okay, it has created a service for me. It has created a deployment for me. So what I'll do is I'll again run kubectl get service, and you should now see a load balancer there as an output. And I'm crossing my fingers so that demo gods are happy with me. And I am just going to copy this into AWS console. Ignore that. And it will take a while. It will not work instantaneously because now it has just launched AWS load balancer in the backend, and now it will have to go ahead and create that deployment, start machines in the backend and host my container pods on these machines. So it is going to take a bit of a while. So I'll just go back, summarize my presentation, and in the end, we'll just come back and refresh this page, and it should be up and running. So from the demo, just to summarize what we did, we created an application defines charts. That was not clear. Let me just go back and show you. Instead of stacks, now you're defining charts. And in the chart, I've created the app.hello, and that's it, as simple as that. So we define this app, define these constructs, the services, the deployments I need. I did synthesize into a Kubernetes manifest file, and I used kubectl apply to actually apply this manifest file, right? Uh, that's it. So if you were not able to see it, okay, sorry. If you're not able to see it in the code, I've just pasted that. So a label would reply label, but a service would actually be written as a service in Kubernetes manifest file, right? Yeah, I just saw the message. I have a lot of time ahead. Let's see. I'm almost to the end. But to summarize, CDK is like an imperative approach to declarative state, right? So it works for any cluster. It is environment agnostic. You can use any Kubernetes API or versions, and even custom resources in Kubernetes with CDK. It's open source. It's not just for AWS. It's for the entire community. And we plan to add more support for languages coming forward. Let's just go and see if our application is deployed or not. Keeping fingers crossed. Yeah, that's it. So we actually deployed this pod or this deployment on EKS using CDK for Kubernetes, right? So there's a lot of things that happen in the backend. So this we created AWS VPC, we created a Kubernetes cluster, we created a manifest file, a simple one though, a manifest file for Kubernetes and applied it all from VS Code. I've not gone to AWS console. I'm not gone to CLIs. I'm doing everything from my VS Code. Now, the best part, now that I have some time to talk about it, the best part is if you notice, you could also create your container images, or even if you're working with something like serverless or something like Lambda, where you need to define your Lambda function, you can now define that Lambda function in the same project, and you can bundle that. There is something called as assets in CDK. So you can bundle that asset in the same CDK project and use the same ID and the same project to actually deploy your entire application onto the cloud. So you don't have to go anywhere else. It's all in the same ID. Everything is happening in the same project itself, and that's what makes it easy. And if you just see my uh, I'll just go down. And if you see my this my main stack where everything is being created, where all these stacks are being instantiated, I could actually go ahead and say, you know what, I want a UAT network, or I want a different network, and you could do that. Now, what has happened here? Okay, one important point. I have not mentioned regions anywhere, right? If you see if it has picked up AP Southeast 1. You can mention regions when you're doing this, but what I've done is AWS IAM has something called as profiles. So I don't think it's too low for you, but what I've done is I've defined these profiles in my configuration files. Okay, and these profiles have certain default. So I've used AP Southeast 1 as my default region for the demo profile. Okay, and that's why it's going and hosting everything in Southeast 1. Now, if I have to give, for example, I have to give it as default. Okay, I've selected default, and I'm just going to CD. Okay, let me just clear this CDK list. Have I still saved this? Okay, just saving this CDK list, and I have a Dev1 network there. So what I'm going to do is just do this or this one. It's going to take a while. Do I have time? Okay, I have 5 minutes more, so I can actually show you this. Let it come back. For some reason today everything is slow with my machine. Just give me a minute. Hopefully it comes back soon. But if it doesn't, we'll see what happens. Okay, it's not gonna come back. It did come back. Okay, so my screen did come back. So it's CDK deploy, and I just say base UAT network, and it's going to actually go ahead and deploy the UAT network stack. And I'm hoping you guys can actually see this, because let me zoom in further. And that should work, and that should do something. For some reason, everything's slow. I think it's my network not supporting me enough today, but it should actually go ahead and show you the code. I'll see if towards the end we can actually see that. So let me finish my presentation. If you want to contribute back to CDK, there's a nice article mentioned how you can actually contribute back to CDK itself. If you want to, we can take a screen capture, or as easy as it is, go to cdkworkshop.com. You can find all, step-by-step process of how you can do CDK, how you can play around with it. If you're new to something, like I'm new to TypeScript, right? So I'm learning TypeScript while I'm working with CDK. So it was a lot of fun for me as well. And there are some amazing other awesome things that people have done. And if you don't have to go here, you just go to Elad B, his GitHub page, and you can find a list of these awesome wrappers and awesome functions that people have created on CDK, which is fun to watch. Like what all people are doing. Okay, this thing as I actually started deploying my base UAT network. So you can see this was recently added, this progress bar, just last week. So you can actually see that when I say deploy my base UAT network, it's actually going to go ahead and deploy everything into CloudFormation. That's, I think that's it. I'm actually doing that in Mumbai. What I do is I'll ask Sarita any questions for me. I think I answered a couple of them, but I'm hoping I can answer more
Hey,
questions.
Rohini, hi. We do have few questions.
Awesome. That means I have reached out to a few of them at least. So happy to answer more questions, please.
Yes. So, does CDK replace CloudFormation template on a longer run?
It won't replace CloudFormation template because I think we have invested a lot in CloudFormation over the years, and to be honest, I still love the service a lot. It's just making, if you're a person who cannot work with JSON or YAML, and you just find yourself struggling with maintaining so many templates, and you just want to work with code that you've always been doing, I think it just gives you another wrapper over CloudFormation. It is not really replacing CloudFormation, and I don't think that's happening in the long run either.
Okay. So, can we do a unit test over the CDK template before applying to see the loopholes that can give any chance to the surface attack?
Yes, actually, you can do yeah, unit tests. I've not shown that, but there is a way to actually test your CDK application. So definitely, whatever you've been doing for your normal code, for your application code, that principle should same apply to CDK. And that's why we say infrastructure as code or infrastructure is code is now with CDK, because you apply the same principles, you apply your same test cases or same methodologies to your infrastructure as code, right?
Okay. So, the
Hope that
last
answers.
one
Yeah.
is CDK region agnostic.
Yes, I think I try to answer that. It is CDK is region agnostic. So if at any places you're not, it is CDK is region agnostic by default. If you can make it specific to any regions, but I would just keep it very region agnostic, and then use these other environment variables and other properties to make it specific for your regions. Because as a design principle, if you keep it more region agnostic, you can, like for me, for example, I normally do my practice in Mumbai region. Anything I want to create, any failed stacks or anything has to happen in Mumbai region. But any demo I do, I will generally do it in Singapore region, because then you don't have to see all the failed stacks and all, right? So it helps you separate your environments. It helps you understand how much you're spending into your billing, like prod versus non-prod, just because I'm hosting into different regions. Or you could also use, and this is a tip maybe I could give, you could use AWS cheaper regions. For example, US East one is the cheapest region that you could find, right? I mean, AWS pricing is region specific. You could host your dev. I mean, if you don't have any compliance issues, or you're okay with some latency, you could host your dev environments into US East. So you pay less for your development environments than what you would pay for your production environment. So being region agnostic works in a lot of ways. Hope that answers the question.
Yes. Well, thank you, Rohini, for the wonderful session with amazing insight on CDK framework using modern programming language. We will definitely